Hello, guys. Welcome to Ramta Solutions and welcome to your last video on transformation geometry. Today, we are looking at enlargement and shrinking. Whether you call it shrinking or reduction, it doesn't matter. All right. Even if you just call it enlargement, it's okay because it depends. If your scale factor is, say, greater than 1, you are enlarging, and if it's less than 1, you are reducing or shrinking an object, right? So remember, when we introduced the topic of transformation geometry, we said it is the study of how shapes can change direction, can change orientation, and the size. Now, this is the size part of that definition. Okay, this is the size part of that definition. So, now here, what are we looking at? Here we are saying, object or shape. Okay, object changes size, becoming bigger or smaller. Okay, let me not put it in a bracket, in fact. Becoming, changes size, becoming bigger or smaller, becoming bigger or smaller. Okay, becoming bigger or smaller. It uses, this one here, uses a factor. Okay, it uses a factor. For now, let's call it factor K. And then the rule for this one here is X and Y. Let's say A, X and Y will give you image factor X factor Y. Okay. Okay. Note, something that I want you to note here is this. Something that I want you to note here is this. K is never 0. Okay. What's this? K here is, I should say this, is greater than 0. It's better to put it like that. So K is greater than 0. Okay. K is greater than 0. So it can never be negative. Okay. It shouldn't be negative. Okay. All right. Now, let's then add more on this part here. So if, again, if K is greater than 1, we are talking enlargement. Okay, we are talking enlargement, zoom. And then if K is greater than 0 but less than 1, we are talking the shrinking. Okay, we are talking the shrinking. Okay, we are talking the shrinking. Okay, we are talking the shrinking. You guys got it? All right. So for this one here, it depends what's given to you. Okay, a question could basically tell you, maybe let me do it like this as an example. Okay, I will say, as an example, given A with coordinates 1 and 1, B with coordinates 5 and 1, C with coordinates 5 and -2, and D with coordinates 1 and -2, I'm gonna say should I say determine the area? Perhaps it might not be that correct, but it's fine. I will say this. I will say yeah. Uh no, I should have said given A B C D colon. Okay, given A B C D colon, A being this and so on. Now draw the image. I'm gonna call the image EFGH when K is equal to 2 and IJKL when K equals half. Okay, when K equals half. So we are going to draw this. But before we draw them, you might want to perhaps say what is this? Perhaps you might want to write the values directly before drawing. I don't know. Maybe let's try that. Okay, let's try that. For our solution, before we sketch it, I will say A, we had 1 and 1. B, we had 5 and 1, if I recall. C, we had 5 and I think it was -2. Let me go back to confirm. Yes. And then we had 1 and -2, right? So we're gonna try here K equals half, and then we're gonna try here K equals 2. Okay, if you recall, we use the rule X and Y giving us KX and KY. Okay, so let's see now. For when K is half, we are getting IJKL, isn't it? We are getting IJKL. So IJKL. For this one, we are getting EFGH. So let's see. This point is X. When you multiply by half, it'll be half. Again, sorry, this one is 1. When you multiply by half, it'll be 1. This one is again 1. When you multiply by half, it'll be a half. This one is 5. 5 multiplying by half, it'll be 5/2. 1 multiplied by half, it'll be half, 1/2. This one is 2.5. Again, this one, it looks like, again, it's 2.5, which is 5/2. Half multiplied by -2. Remember, y value multiplied by k. Our k is half. So half multiplied by -2 will be -1. In the same vein, we have here 1 multiplied by half is a half. -2 multiplied by a half is -1. Okay, cool. Now for this one here, we have, let's remind ourselves, we have 1 multiplied by 2, it'll be 2. Remember, x value multiplied by 2, y value multiplied by 2. Y value is still 1, so it's still going to be 2. X value is 5 multiplied by 2, it's going to be 2. 1 multiplied by 2 is 2. 5 multiplied by 2 is 10. Oh, I messed up here. It's supposed to be 10. Right, it's 10 and 2. So this is 10 and 2. Now this one here is going to be 10, right? 5 times 2 is 10. Negative 2 times positive 2 will be negative 4. Cool. 1, positive 1 multiplied by 2 will be positive 2. Negative 2 multiplied by positive 2 will be negative 4. This is enlargement. Okay. So let's see how this one works. Okay. Let's see how this one works. We're going to try it. I'm going to go to the next page and we're going to have our grid. Okay, I'm going to use a grid. This one is too small. Okay, this one is too... Okay, I think this one is... nah. Okay, I think... Okay. Better? Yeah, I think this one is better. What is the low... Oops. Come on, buddy. Okay, better. What is the low... What is the lowest y value we had? The lowest y value we had was negative 4. And the highest x value was positive 10. The lowest x value was positive half. And the lowest y value was negative 1. No, it's negative 4. Highest y value is 2. So I can say my highest y value will be 4. So let's just draw it. Okay, let me change the color. So this is what I'm going to do. Just want to make sure that I have the right thing here. Okay. I think I should enlarge it a bit. I think I should enlarge it a bit. I think it's better now. Yeah. Okay. Now, 1, 2, 3, 4. Okay, let me just have it here. Yeah, I think it's better. This one. Oh yeah. Perfect. Okay, so let's see. With the y value, I said it'll be Mwebedi Taro Ne Kano, doesn't matter. Yen 2, 3. Fir faith says, yeah. Negative, 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 negative. I should use a smaller font size. Negative 1, negative 2, negative 3, negative 4, negative 5 doesn't matter. Honestly, to get to negative 5 is not necessary. Now let me use a bigger one. Mojambele Tatu Ne Tanusita Saba. Hey, what is 8? I forgot. 9 and Kumi. And 11, right? Swahili. Okay. All right. Now we have x values here. Okay. I want to see, I do recall that this looked like a rectangle. So I want to see if I can get a rectangle in my objects here. The blue one. I don't like a blue one. No, I want one that's filled. Yeah. See, somehow this one gives me. Okay, I will have to draw it myself. It's fine. So let's see. Point A was 1 and 1. Where is it? Here is it. Point A was 1 and 1. Here is it. And then point B. So here's point A was 1 and 1. Point B was 5 and 1. 5 and 1. Here is it. This is point B. Point C was 5 and negative 2. 5 and negative 2 is this one here. That's point C. And then point D was, where is it? Point D was 1 and negative 2. Here is it. This is point D, right? So let me just do this. And then I'm going to color them in. Okay, just to use this, let me color it in like this so I can still see my numbers. Okay. Now let's go to the enlarged when k equals 2. When k equals 2, if my memory serves me well, when k equals 2, we can go back and check time and again. E was 2 and 2. All right. E was 2 and 2. E was 2 and 2. Where is it? Here is it. And this is point E. Now we're going to F was 10 and 2. F was 10 and 2. Here is it. This is point F. It was 10 and 2. Then G, 10 and negative 4. 10 and negative 4. Here is it. This is G. Lastly, H, 2 and negative 4. 2 and negative 4. 2 and negative 4. This is H. Again, let me just connect them. Okay, let me just connect them. Okay, and then what kind of a highlighter am I going to use? I notice there's no white. So let me just say I'm going to highlight like this, guys. Just so I don't highlight over the existing color. Okay. Okay. Do you guys see this? It's way bigger than the first one. Now, the other one was was shrinking when k was half. I was half and half. Let me go check. I was half and half. I might need to use a smaller font size. I was half and half. Here's I. Oops, I should use a red. Here is it. Half and half. All right. And then J was 2.5 and half. 2.5 and half. Here is 2.5 and half. This is J. Now, we then go to K, 2.5 and negative 1. 2.5 and negative 1. Here's 2.5 and here's negative 1. Then we go to, there was K, by the way. There was K. Then K, man. Then we go to L, half and negative 1. L is half and negative 1. L is half and negative 1. Here is it. This is L. Now look at this. Do you see this? Do you see this, guys? So this portion here, okay, I can just highlight it. It's okay. Okay. Now let me remove the grid. I'm okay with it now. Do you see now? This is enlargement or shrinking. Can you guys see it? This is how it works. Okay. This is how it works. Okay. Do you guys see it? Look at it. The original was A, B, C, D. Now, when you now say enlarge it by a factor of 2, let's perhaps start with the areas. Okay, let me maybe calculate the areas. So now I want us to calculate area of area of A, B, C, D. A, B, C, D looks like what shape, guys? A rectangle, right? Indeed, it looks like a rectangle. So let's convince ourselves that indeed it's a rectangle. What is the distance between A and D? 1, 2, 3. What is the distance between A and B? 1, 2, 3, 4. Indeed, it's a rectangle. So it's going to be a rectangle with units. 3 times, what did we say? 4. Yeah, 3 times 4, which is 12 square units, isn't it? Perfect. Now let's look at area of E, F, G, H. Let's look at it. Okay, let's look at it. Now with this one, from E to EH, what is the distance? EH, 2 minus 4, it's 6, isn't it? It's 6, right? But let's confirm. 1, 2, 3, 4. 5, 6. Indeed, it's 6, right? So it's 6 units multiplied by what is the length? 10 minus 2 is 8. So this is 6 times 2 is 8. Let's convince ourselves. 1, 2, 3, 4, 5, 6, 7, 8. Okay, what is 6 times 8? 6 times 8 is 48, isn't it? It's 48 square units, isn't it? 48 square units. Is that so, guys? I'm not sure. Is it 48? Indeed, it's 48 square units. Lastly, let's look at area of I, J, K, L. What is it? From Ooh, with this one, we have to be very careful. From I to L, I do recall that the x value of L was, rather is, the y value, not x value. The y value of L for now, it's -2. So from, no, is it -2? No, it's -1. So from positive half to -1, this looks like it will be 1.5, isn't it? It will be 1.5, which is 3/2. Now, let's look at the horizontal distance. 2.5 to 0.5 must be 2 units, isn't it? Must be 2 units. So what is this? This is, somebody please confirm. I'm not sure. I'm also going to confirm the values. Indeed, it's, okay, 5.5 minus half. I want to convince myself, yes. So not 5.5, 2.5, 2.5 minus 0.5 will be 2 units indeed. So it's correct. And then 1 plus half will be 1.5, 3/2. So what is our answer here? It's 3 square units. Right? Our answer here is 3 square units. Right? Our answer is 3 square units. Is that so? I'm not sure, guys. I'm not sure. But you guys can confirm. You guys can confirm if indeed this is the right thing that we did. So now, what are we trying to achieve here? Was our factor really was our factor really was our factor really half, and was it really 2? I want you to now look at this. When you look at the areas, area of the original and, let's say, or image over original, you will realize this. Look at the image for EFGH. It's 48, and what is original? It's 12. What is 48/2? It's 48/2 is 4, right? Square root of 4 is 2. Now you look at, again, image of, for example, area of IJKL is 3 square units, and then original is 4. What is 3/4? 3/12. 3/12 is 1/4. What is the square root of 1/4? It's half. And this is you saying, okay, we are right. And this is how we look at enlargement transformation. Okay? This is how we look at enlargement transformation. Maybe this last point, let me emphasize it here. Saying area of ABCD over area of, not ABCD, buddy. Area of EFGH, the image, over area of the original ABCD. When you look at it, this is 48 square units. over 12 square units. What is it? It is 4, right? It is 4, isn't it? If you were to, again, if you were to say the length of whatever side, let's say length EH over length AD, you will realize that you will realize that you get exactly 2 to show you the scaling factor. Therefore, our factor is square root of 4, which is 2. You can do the same with A. Okay. Remember what I said to you. If you use any of the two sides you want to compare, if you compare EF and AB, you will realize that when you say EF, if you recall, EF was 8 units, AB is gonna be 4 units. So 8 over 4 will be 2. Okay, so in other words, when you use length, when you compare length, you are going to get your factor as is. When you use areas, you will need to find the square root of that area. Okay, and this is how you do your enlargement transformation. Okay, just like that, we are. Okay, so this is it, guys. See you next time, and bye bye.